Okay, so once again, good morning everyone. So our topic for today is the introduction of the system design and implementation. But to be specific, our topic actually is the software design challenges or the design and software development. No? So for today, the software design phase has evolved from an ad hoc and sometimes overlooked phase, no, to an essential phase of the development life cycle. So furthermore, the increasingly complexity of today's system has created a set of particular challenges that makes it hard for software engineers to meet the continuous customer demand for a higher software quality. So the challenges have prompted software engineers to pay closer attention to the design process to better understand, apply, and promulgate well-known design principle processes and professional practices to overcome these challenges. So some of the major challenges include the requirements volatility, no, design process, quality issues, specifically when it comes to performance, usability, and at the same time, especially at present, security and others. So distributed software development, efficient allocation of human resources to develop tasks, limited budgets at the same time, no, unreasonable expectation and the schedules, fast changing technology is also an issue, and accurate transformations from software requirement to a software product. So to give us more details now about the discussions, let us all welcome our first presenter. Sir, go ahead.
And thank you so much, Sir Abante, for that introductions. So again, good morning, everyone. So my topic for today is about the challenges of software design. So software design, the purpose of software remains the same today as it was the beginning of computing in the 1940s. And the purpose is to automate the solution of complex using computer. However, the nature of the problems to be solved has changed dramatically. So the programming techniques employed. And programming techniques have also advanced in the decades that follows the 1940s through the use of the languages of increasing power and abstraction. Instead of manipulating instructions at the level of hardware, programmers specify data and algorithms in terms of the problem domain. Instead of building new standalone system, software development is often used to enhance a company's enterprise information capabilities by building new functions into an already existing system to carry out new services. Okay, so this is just an overview about the software development. So since 1940s until today, so we have here one purpose why we are using a software is just to automate the solution of complex using computer. So from the start, naroon na yung purpose natin why we are using computer. But however, since the problem has changed or as time pass by, no, so yung demand ng ating mga yung demand ng nasa paligid natin ay syempre ay nag-i-increase din or nag-i-evolve in a more complex scenario. So hindi na enough or di na sapat yung just use a basic computer or some basic applications for us to solve different complex problem. So that's the reason why programming techniques employed. So programming techniques as advanced in the decades of follow through the language of increasing power and abstraction. So since tumataas yung demand ng ating mga sabihin natin yung mga problems na na-encounter as year pass by, so kailangan yung mga programming techniques din na ini-implement ng isang programmer or isang company ay kailangan makasabay din dun sa demand na hinihingi ng isang community or ng isang company. So the more na tumataas yung demand dun sa mga complex problem, sumasabay naman yung evolution or yung pag-i-improve, pag-develop ng iba't ibang mga high power, or sabihin natin na yung mga different languages and abstraction na kailangan gamitin when it comes sa programming techniques. No, and through that, programmers specify data and algorithms. So they observe na hindi sapat yung simple computer hardware or simple computer applications para makasabay doon sa demand ng mga complex problems. So naisipan nila na gumamit ng mga data and algorithms para yung traditional process ng kanilang system is mapalitan ng mas high-end na program na kanila dinidevelop. So, sabi nga, instead of building new stand-alone system, software development is often used to enhance company enterprise. So, before, ang isang company ay may na-establish na system. So, once na nagkaroon ng evolution or in-need i-upgrade yung system na existing, kailangan ulit mag-develop ng panibagong system. Pero dahil nga sa mga bagong languages or mga programming software, imbes na mag-develop again ng bagong software, ang ginawa na lang nila ay nag-isip sila ng isang program na kung saan hindi na kailangan alisin yung existing na software na ginagamit, kundi kailangan na lang ito i-enhance or i-modify na hindi naapektuhan yung information na existing na doon sa isang program. So ganun nag-evolve or ganun na-develop yung software before. So from the automated or using basic computer software or basic applications, pumasok yung programming techniques at na-apply yung mga high-end or powerful languages, programming languages. And kasabay nun, nagkaroon na ng modification and upgradation dun sa mga existing na system na meron ng isang company or isang industry. Okay, so another factor has risen of profound significance for the software industry, which is the pace of change and introduction of the new technologies. Okay, so since nag-upgrade na tayo ng system, nakakapag-develop na tayo ng mga bagong program, hindi naman pwede na yung hardware or yung computer natin is the same or hindi rin pwedeng hindi makakasabay dun sa evolution ng mga programming languages or mga programs na dinidevelop. So because of that, so nagkaroon na rin ng demand when it comes sa mga new technologies na kailangan gamitin. Yung mga pag-upgrade ng mga computer units, nagkaroon na rin ng mga sabihin natin na may high-end na mga specifications na computer na kailangan para yung compatibility ng program na gagamitin is intact dun sa hardware or sa technologies na i-apply ng isang company or sa industry. So, the concept of model drive architecture or MDA aims to alleviate this problem by focusing developer effort at higher level of abstraction. In the creation of platform independent models or PIMS, from which version of the system appropriate to particular technologies, languages can be generated semi-automatically using platform-specific models. So the model drive architecture, this is just this is a sabihin natin a design wherein yung mga program na iraran or i-develop na isang programmer ay meron na siyang malinaw na or meron na siyang clear structure kapag ito ay i-develop or kapag ito ay create. So using this MDA or model drive architecture, so the owner of the program and the programmer has a one vision, has a clear structure kung ano at kung paano mag-run or mag-generate yung program na i-deploy or i-execute. And using different platforms like yung platform independent models and yung platform specific models, using these models, so nagkakaroon ng mas easiest, mas reliable na information generation dahil nga nag-a-upgrade or ito na yung pinaka-sabihin natin na latest design for a program. So next we have, so this is an example of the MDA process. So we have here yung platform independent model. So from one model, na-transform siya into 2 platforms. And next, nag-generate rin siya ng to implement yung implementation na ng programs. So nagkaroon din siya ng 2 platform. So from one model ay bigla nagkaroon ng 2 platform do sa transformation niya, and then when it comes to sa code generation, nagkaroon ng 2 system na i-implement. So ganun yung parang design ng MDA process. So the software development method. Software development method is a systematic means of organizing the process and products of a software construction. So yung software development method natin is a process of organizing the process and products of a software construction. So ito yung method na kung saan ay kailangan i-follow to make a systematic and organized process and product software. So using this method, magkakaroon ng guide ang isang programmer or even the user of the program kung ano or saan na anong part na ng program yung kailangan i-prioritize at kung ano na yung update doon sa i-deploy or ipa-process na program. So the software development methods typically consist of notations or languages, a process, and a tool. So notation or languages are to describe the artifacts being produced. So ito yung mga input, yung mga data na kailangan para dun sa i-develop na software. So the process, defining the sequence of steps taken to construct and validate artifacts in the method. So ito yung sabihin natin stages or yung steps on how to create the software and to validate the artifacts na nandun sa software. And tools, of course, to support the method. So one of the example of this sabihin natin a software development method is the waterfall model. So I know naging narinig nyo na or naging familiar na sa inyo yung ganitong waterfall model. So the stages of development such as requirements definition, design, and implementations are separated into complete tasks which must be fully carried out and signed off before the next task can be started. So each stage produces a deliverable which is intended not to need for much further revision. Okay. So sa waterfall model, so before the task or before the next stage will executed, it must be all the requirements needed for the first stage should be completed or fulfilled. So meaning to say, dapat ma-meet muna yung mga requirements needed doon sa first stage, which is requirements definition, before mag-proceed doon sa another stages, which is new system and system and software design. So once na hindi na-meet or hindi satisfied yung do sa unang stage, yung requirements niya, so hindi siya magpo-proceed dun sa next stage. So sa waterfall model, nagkakaroon ng sabihin natin na delays dahil nga bago tayo makarating doon sa mga susunod na stages, kailangan makomplete muna yung requirements or yung data na kailangan doon sa first stage. But the good thing sa waterfall model, malilesen natin yung mga errors, malilesen natin yung mga sabi nating revisions dahil doon pa lang sa isang stages malalaman na natin kung ano yung mga kailangan pa nating idagdag or i-input bago tayo mag-proceed doon sa next stage. So doon pa lang sa unang stage dapat fully furnished na yung mga kailangan natin para mag-proceed tayo doon sa sunod na process. So yun yung kagandahan ng waterfall model. So nakukumpleto muna natin yung mga requirements or yung mga data na kailangan bago tayo mag-proceed sa next stage. So naliles yung ating revisions. Naliles din yung ating yung mga errors kapag in-execute na yung program. So next, the spiral model. The spiral model is based on an iteration of incremental development steps. Each iteration or cycle of the spiral produces a deliverable, such as an enhanced set of models of a system or an enhanced prototype of a system. In each iteration, a review stage is carried out to check that the development is progressing correctly and that the deliverables meet the requirements. So, ang pinagkaiba naman nito sa waterfall model, si spiral model, kahit hindi complete or kahit partial lang yung data o yung requirements na kailangan sa first stage, pwede na siyang mag-proceed doon sa next stage. And then to the following stage. Dahil in this image, makikita natin na bawat cycle, so binabalikan niya, chine-check nung spiral model if may development doon sa mga naunang requirements na kailangan hanggang sa ma-fulfill ng spiral model yung implementation. So sa spiral model, may mga chance na pwede mong balikan, pwede mong i-improve, pwede kang mag-add ng mga requirements or data na kailangan for the implementation of the system. So yun naman yung ang problema lang dito sa spiral, syempre paulit-ulit yung magiging process. So may mga chance na pwedeng yung data or yung information na ilalagay mo sa system, sa isang software system, ay pwede mong i-check or pwede kang mag-update every stages nung sa spiral model. So, kahit hindi pa siya complete or partial pa lang yung mga nilalagay mo na sabi natin requirements, pwede nang mag-run yung spiral. Kaya lang, it will take time kasi nga kailangan mong i-check kung nagkakaroon ba ng progress dun sa bawat stages. Next, we have the Rational Unified Process or RUP. So the Rational Unified Process has 4 phases in the development process. So una ay inception. So inception defines a project scope, goals of the system, evaluation of its feasibility, and general estimate of project cost and time. A prototype may be built to assist in checking if the project is viable. The main process in this phase is requirements definition, producing initial use cases in agreement with the user. So, dito naman sa rational unified process under inception. So, ito yung parang sabihin na natin na project o yung proposal ng isang software na i-develop. So, naroon yung mga requirements na kailangan like yung scope, yung goals ng system, para saan yung goals na yon, and then yung evaluation of feasibility. So, yung study nung gagawin natin, nung i-develop na software, at yung cost and time na pwedeng gamitin, yung mga resources na pwede nating i-spend doon sa pag-create ng software. So a prototype may build and assist in checking if the project is viable. So ito yung parang initial stage kapag si user ay gustong magpa-develop ng isang software. So naroon yung mga requirements and data na kailangan i-provide ng isang user. And then yung elaboration, requirements, analysis, and definition of architectural design. The use of a overall architecture of the system. So ito naman, ito yung part ng isang developer o isang programmer na kung saan i-explain niya doon sa user kung ano yung mga pwedeng i-develop or pwedeng maging cover noong mga anong system na ipoprogram or i-develop. So naroon yung design kung paano magra-run yung or paano mag-execute yung software na i-develop ng isang programmer. And then the construction, so the design and implementation through the development of prototypes, culminating in the delivery of a beta version of the system to the user. So this is one, the construction. Ito na yung meron ng i-develop or meron na isang beta version doon sa software na dinevelop ng isang programmer. So makikita na dito yung design kung ano yung interface ng software and the implementation, how the program or the software works. So using the beta version, magkakaroon ng idea yung user if the software meet his or her expectations. So it is a construction. Okay. Right. And then the transition, the testing, correction, and detected by users. Roll out of new version until the production version is reached. So after the beta version of the system, so magkakaroon na ng transition. Ito yung dry run. Sabihin natin na kung saan yung program is fully fully executed na, and then doon na i-evaluate ng user kung may mga kailangan bang idagdag or kailangan i-delete, kumbaga may modification na magaganap between the programmer and the user. So yun yung stages ng rational unified process, the inception, yung introduction or yung mga requirements needed ng isang programmer, elaboration, how the program run, so explained by the programmer, what are the requirements, what will be the process or what will be the flow of the software that he or she will develop, the construction, yung the interface and the execution of a beta version of the system, and the transition, which is the transition is the execution of the program and the modification of itself. We have here the extreme programming. So extreme programming tries to minimize the complexity of following a particular development process. Instead of prescribing a rigid set of development steps and milestones, it emphasizes a number of practices. So this extreme programming ay minimize niya naman yung complexity or yung mga sabihin natin yung maraming process na or maraming steps na kailangan i-follow kapag gagawa ng isang software or isang program. So sa extreme programming, just only 4. One is the realistic planning. Second is the small release, metaphor, and last is simplicity. In realistic planning, customers make the business decision about a system. The developer makes the technical decision. Plans and reviewed and revised as necessary. So doon pa lang sa first steps ng extreme programming, which is yung realistic planning. So si client ay meron na dapat na isang clear vision or isang clear plan on what kind of software the programmer will develop. And as part of the developer, so i-explain niya kung ano yung mga technical decision or yung mga sabihin na natin yung mga flow or yung content ng program na gagawin niya based dun sa decision or business decision ng client. So, dun pa lang sa stage na to, nagkakaroon na ng interaction between the programmer and the user. So, naliles yung time dahil dun pa lang sa first stage ay parang kiniklear na nila or nagkakaroon na sila ng malinaw na vision or plans doon sa software na i-develop. And then sa small release, a useful system quickly and release updates at frequent interval. So ito yung part na pwede natin sabihin this is the beta version of the program wherein they just implement or execute a system and also yung updates or yung modification ng program is hindi ganun katagal at pwede siyang i-modify time to time. So ganun. So metaphor, all programmers should share an understanding of the purpose and global strategy of the system being developed. And simplicity, design everything to be as simple as possible instead of preparing for future complexity. So sa simplicity, as simple as good, kasi nga kailangan sa software or sa program, user-friendly yung i-develop na software. So hindi siya ganun complicated, especially kung ang user nito is not totally knowledgeable when it comes sa computer or sa software. So much easier kung yung design ng isang program ay very basic and user-friendly. Next is testing. Both customer and programmer write tests. The system should be frequently tested. So sa testing naman, ito yung si customer at si programmer ay magkakaroon ng interaction when it comes dun sa testing ng system. So si customer magbibigay ng kanyang insight when it comes dun sa program na in-execute and at the same time ganun din si programmer kung may nakikita pa siyang possibility na pwede pang i-improve or i-modify in the simplest way yung program. Next is refactoring. The system should be restructured whenever necessary to improve the code and elimination of duplication. So, yun yung refactoring, no? So, anytime, kung sakali mang may changes dun sa side ng customer or ng client, the software is easily restructured and improve the code and elimination of duplication. And pair programming, put programmers together in pairs. Each pair writes code on the computer. So syempre, in creating or developing a program or a software, hindi naman siya kaya ng isang tao lang. So kailangan talaga at least 2 or more programmers yung possible na mag-develop ng isang programs dahil they will share ideas, they will share insights on how to create or how to develop a program or a software. Collective ownership, all programmers have permission to change any code as necessary. Right? And continuous integration. Whenever a task is completed, build a complete system containing this part and test it. So, continuous integration. Ito na yung pag-execute ng complete and fully functional na software. And 40-hour week. Don't work extreme hours to try to compensate for planning errors. So, no need naman na the whole week is yung planning errors lang yung i-work out mo para lang maayos or sabihin na natin na magkaroon ng yung plan is fully furnished na. So, no need naman na the whole week, yung 8 hours mo per day is yun lang yung pwedeng, yung planning errors lang yung i-work out. So, on-site customer, an actual customer of the system should be available at all times. So, yun nga. So, once the programmer reach the customer or the client should be available anytime. So, kapag nagkaroon ng question or nagkaroon ng, sabi natin, curiosity yung programmer when it comes dun sa mga data or information na ibigay ng client, dapat si client is easy to reach para hindi nagkakaroon ng delays when it comes sa development ng software. Coding standards, follow standards for self-documenting code. So sa part ito ng mga programmer, so dapat kung ikaw isang programmer, isang developer, so hindi dapat pabago-bago ng languages or programming language. So once na nag-start ka na ng programming mo, dapat yung codes mo ay hindi papalit-palit. So dapat kung gumagamit ka ng Java or other supporting codes, so yun lang dapat, dun lang dapat iikot yung codes na ginagamit mo. So hindi ka pwede kumuha sa ibang mga software basta para lang i-indicate do sa program na ginagamit mo. So dapat standard. Hindi dapat pabago-bago yung code or programming language na gagamitin. So extreme programming or XP is a lightweight development approach which aims to avoid the time-consuming documentation and structures of other methods. Code can be written immediately after definition of use case. The code produced can then be refactored and restructured to produce a more efficient and maintainable implementation. So yun yung sinasabi natin na extreme programming. Next, we have here the software development steps. Okay. A number of stages are typically present in any software development projects, regardless of the development model and methods chosen. So, doon sa mga nauna nating software development steps or methods, meron silang mga guidelines or guide procedure na sinusundan when it comes in developing a software or in a program. So, in this part, we have here an example of a system to play a Scrabble against human players. So we will use a Scrabble program or a system for this part. So we will explain how these steps or methods connected to a system of Scrabble against human players. So first, we have here the feasibility analysis. So this stage evaluates the technical options for implementing the system, determining if it is feasible to implement, and if so, if there is a cost-effective implementation. So this stage can be carried out as part of the risk analysis phase in the earliest iteration of the spiral model or the first step in the waterfall model. So background research may be needed to investigate similar systems that already exist and what services are available to carry out parts of the required functionality. So trial implementation, prototyping could also be a carry out or mathematical estimation. So using the feasibility, this is the research or the study of the a system to be developed. So for example, in the Scrabble system using against human players. So this stage should investigate the different techniques, different sabihin natin yung memory storage na gagawin ng isang developer. So i-analyze niya or gagawa ng isang study when it comes doon sa pwedeng maging sabihin natin na yung content o yung inside the system about the feasibility, yung study niya, yung kung ano yung mga possible na pwedeng i-input doon sa development or doon sa creating ng program. Next is the requirements definition. So this stage systematically records the requirement that the customer or customers of the system have for it and the constraints imposed on the system by existing systems that it is required to operate, with including existing work practices. Okay, so dito sa requirements definition, ito yung mga kailangan natin i-identify as a programmer kung ano yung mga functions ng isang system. Example dun sa ating Scrabble system. So ano yung mga pwedeng functions na pwedeng i-access ng human player compared dun sa pwedeng i-access ng computer or ng isang AI. No? So yun yung mga kailangan clear when it comes sa dun sa ating example na system Scrabble or sa Scrabble application. And then the use case model unified modeling language can be drawn for either system to make clear what users or external system are involved in each functional requirement. So yun yung this is the example of the use case models. No? So nakikita natin yung requirement na pwedeng i-access na isang human player compare dun sa AI or dun sa computer the player. So si human player ay meron siyang different functions na pwedeng gamitin compare dun sa AI na minimal lang or limited lang yung pwedeng i-access. So yun yung requirements definition.
Ano? Picture mo.
Okay, so let's proceed with the analysis. This stage builds precise models of the system. Using suitable graphical or mathematical notations to represent its state and behavior in abstraction, platform-independent manner. In the critical system formal validation that the analysis models satisfy required properties would be carried out. So dun sa analysis steps natin, so this stage has a clear and precise study, no? So sabihin natin yung precise study models niya. So dapat, for example, yung ating application ng Scrabble, So, kung ano yung image or yung sabihin natin yung properties ng isang Scrabble game using yung actual, dapat the same din siya doon sa gagawin nating analysis ng ating software. Especially dun sa mga value ng mga letters, yung mga conditions na meron sa board. So, yung analysis nun dapat fit doon sa kung ano yung
Magkano nga ulit po yung stock knock niyo?
Dos.
Dos? Tapos ito, 8 na.
okay. So, doon sa analysis stage po natin or sa analysis steps. So, if we can see yung how to play the Scrabble game with a board o yung literal na Scrabble game. So, meron siya yung mga letters with a corresponding numbers no sa taas. So, dapat kung paano yung value ng bawat letters with na may corresponding numbers, kapag inilagay natin siya sa software, dapat the same lang din yung magiging value niya, and at the same time, yung analyzation niya, kapag nirun na yung software, especially yung mga computations, how to get the score of a player. So, doon papasok yung steps ng analysis. And the design naman, so this stage define the architecture and structure for the implementation of the system, typically dividing it into the subsystem and modules, which have responsibility for carrying out specific parts of a parts of its functionality and managing parts of data. So this is the graph or the example of the analysis model of Scrabble player. So you can see no, yung mga functions ng bawat functions ng system. Kapag nag-create ng pag nag-create tayo for example yung Scrabble game. So naroon yung value yung nakikita natin sa board, and at the same time yung tiles na ginagamit sa Scrabble. Even yung mga computations ay nandun din. So dapat well analyze yung pag-develop or pag-create ng application or ng software. Okay. So next is we have the architecture design, or what we call this one are the under siya ng design steps ng ating software development method. So this sa design, we have here the architectural design. So define the global architecture of the system as a set of major subsystems and indicate the dependencies between them. So this is an example of architectural designs. So we have the graphical user interface, wherein the player and the administrator, yung game management niya, so yung sabihin natin yung instruction, how to play the game, which is under the functional core, yung mga movements or yung mga turns na gagawin ng player, and then it will check dun sa data repository if the movement or the move of a player is valid or invalid. So that's how works the architectural side for the software development. Next is the subsystem design. The composition of these global systems into smaller subsystems with which is handle some well-defined subset of its responsibilities. The process continues until clear identified modules emerge at the bottom of the subsystem hierarchy. A module typically consists of a single entity or group of closely related entities, operations on instances of these entities. So kung mapapansin natin, yung design natin kanina, so ito yung tinatawag natin ng mga subsystem design, no? Itong mga functions or mga pwede yung makikita natin doon sa system na dinevelop natin. So this is just the flow and this is itong mga to, yung mga player movement game, ito yung sinasabi natin na subsystem design. Okay. So next we have the module design. Module design defines each of the modules in terms of the data encapsulates, the properties, and the operation it provides. So the data encapsulates a list of attributes and their types or structure. So ito yung mga storage data na magbe-verify doon sa ating example na sa Scrabble, no, to verify if the movement or the turn of a player is valid. So dito i-check yung dito papasok si data encapsulations kasi doon sa dictionary na naka-program doon sa ating application. So i-check doon kung yung word na in-input ng isang player is valid or invalid. Next, the properties. It is responsible for maintaining and or ensuring that the operation is true whenever this is not in progress. So ito yung mga properties na ginagamit sa mga games na kung saan ay hindi man siya nagagamit during the actual games or the actual execution ng isang software or ng isang application, na-maintain niya or na-ensure niya na hindi ito or walang error na nangyayari during the execution of the application or the software. Okay, next, the operation it provides. So ito yung mga sabihin natin yung mga inputs or yung mga data needed for the games or for the application. So for example, their names, input and output data, and the specification. So this is called the interface of the module. So yun yun, no? Pag nag-start ka ng isang application of ng isang software, so kadalasan ang may hinihingi doon na sabihin natin yung username mo, something like that na doon papasok yung the operation it provides or yung external services ng isang software or isang application. Next is the detailed design. So for each operations of the module, identify the steps of each processing. So specialized form of design include interface design. Interface design is to plan the appearance and sequencing of dialogues and other graphical interface elements for the user interaction. And database design is to define the structure of a database for the system and what queries or updates will take place on it. So sa interface design, naroon yung, of course, yung appearance and yung appearance sa isang software or ng isang applications once na ito ay in-execute na ng isang user. And then naroon din if yung dialogues or yung mga message boxes na nag-a-appear once na a user input an invalid data. So yung mga ganong design sa interface. And the database design naman, so ito yung mga design na kung saan the software or the system will show or will notify the user if their database is need to upgrade or to expand the capability or the capacity of the database. And next, the pure top design, in which a system is hierarchically divided into subsystems. and this in turn into further subsystems and modules. It is an idealistic model which can lead to expensive backtracking and rework if applied without a regular review. So yun yung mga activities inside our software development steps or designs. Next is the implementation. This is the execution of a program or the software that we are created. So this stage produces an executable version of the system by translating the design modules into a program language code. So implementation may initially be performed for a small part of the system, which act as a template or a proof of concept for the remainder of the implementation. So ito na yung sabihin natin pagrara ng ating software or ng ating system, which is the implementation. So after the creation, the development, so this is the implementation. So the user can now have an access, can use the system or the software. So ito yung mga reference ko, yung mga pinagkuhanan ko ng data. And that's the end of my presentation. So thank you so much for listening, and I hope you learned something about my presentation.
Okay, so once again, thank you very much, sir, for your comprehensive discussions of the topic. Actually, I'm so happy that you just introduced the entire coverage of the advanced system design and implementations. So to give some summary of the discussions, no, as what I mentioned earlier, no, there are certain software design challenges, no. A while ago, our presenter mentioned about the technology, no, the fast changing technology. Okay, number one, actually, design challenge is the requirements volatility, as I mentioned. No? So a major reason for the complexity of software project is the constant change of requirements. No, especially if you are dealing with the government, sorry to say, no, especially if you are dealing with the government, no. So when designed properly, software can be modified or extended easily. However, when designed poorly, modifying software can become overwhelming and lead to all sorts of complex problems. Again, as our presenter mentioned earlier, no, we need to do a good design. No? So unlike the development of computer hardware, no, bridges, houses, or mechanical parts, software's very own nature allow itself to change to provide different or new functionality to systems. No? The same trait that makes software so desirable is what makes it also so complex. Although much effort is put in the requirement space to ensure that requirements are complete and consistent. So rarely that is the case, leaving the software design phase as the most influential one when it comes to minimizing the effects of the new changing requirements. So requirements volatility is challenging because they impact future or already going development efforts. And this forces designers to create design that provide solutions to problems at a given state while also anticipating changes and accommodating them with minimal effort. And this request, no, or this requires designers to have a strong understanding of the principle of software design and develop skills to manage complexity and change in software development. So that's why our presenter really, no, gives some importance of the different
Mute po kayo, sir.
okay, then there's certain problem with my colleagues, no, in now the another challenges, as actually our presenter also discussed this one, will be the process. In software engineering, again, when we say software engineering, this will be a process-oriented field, right? The software processes all allows engineers to organize the step required to develop software solutions with schedule and cost constraint. I think everybody also finished your project management subject during your undergraduate program. So therefore, at the core of every software development company, there should be a sound, well understood, and consistent process for software development. No? Processes can also be developed and customized for particular phases of the software engineering life cycle. So in the design phase, software processes involve broad set of activities and tasks that bridge the gap between requirements and constructions while adhering to a set of project-specific or a company or organizational specific constraint. And these activities include common ones such as architectural and detailed design, as well as other supporting management activities. And these supporting activities include establishing a design review process, defining design quality evaluation criteria, evaluating design reuse, establishing design change management and version control procedures, design tool adoption, resource allocation, and others. So in many cases, an organizational design process is not well established or poorly understood or approached with minimalistic expectation that ignores aspects that are essential to executing a successful design phase. Now, because focusing design efforts on creating independent software products, excuse, such as a simple class diagram or user interface while ignoring other design activities may create complexities later or during system test and maintenance. So a while ago, our presenter gave you an example of a simple class diagram. Now, the design process is challenging because essential design process activities are often overlooked, done in an ad hoc manner, or simply not done at all. So in many cases, a well-established and carried out design process serves an indication of a future project success. Number 3, of course, is the technology. No? We are all IT practitioners. The majority of us are IT practitioners. Software is meant to be everywhere. So from healthcare system, education, defense, and everyday ubiquitous devices, software is required to operate on a massive and always evolving technology landscape. Besides the operating environment, the technology for designing and implementing today's software system continues to evolve to provide improved capabilities. Let's say, for example, of this include modeling languages and tools, programming languages, development environment, design patterns, and design strategies. So as new technologies emerge, software engineers are required to assimilate and employ them all at the same time. No? In some cases, emerging technologies do not completely replace old ones. And some, our presenter discussed a while ago, that that at present, we need also to consider the old ones. Some software systems are required to interoperate with old legacy systems design, with older design methodologies, and this result in software designers employing a myriad of design methodologies and technologies, all on the same software system. So in other cases, design models need to be derived from existing code and of course modified and made interoperable with newer technologies. And this technology-driven aspect of the design phase creates a demand for capable software designers that can assimilate new technology quickly and effectively in order to succeed at designing software. So the technology aspect of software design is challenging because it is the fast and ever-changing. Therefore, designer must keep abreast of the latest advances and become proficient in the application of this advancement while maintaining rooted in legacy technology. Number 4 design challenge is the ethical and professional practices. Actually, we have a very good technical expertise, The Filipino people are very good in designing. The Filipino people are very good in programming, a very good software engineer, and so on. But sometimes the problem will be the ethical and professional practices. No? Designers create blueprints that drive the construction of the software. So during this creation process, designers are required to determine how design decisions affect the environment and the people that use the software. So in many cases, no? So again, no, the software development process is traditionally carried out under tight schedule constraint. So inherently, all phases of the development life cycle suffer from this because our presenter mentioned earlier, no, that we need to finish this task before we proceed to another. No? This is clearly stated a while ago by our presenter because all phases of the development life cycle suffer from this, no, including the design phase. And this creates external pressures that can lead designers to deviate from the normal design approach to meet these demands, which can have catastrophic consequences. No matter how tight deadlines are, how much animosity exists within the design team, or how much other external or personal factors are brought into the design phase, software designer must exhibit strong ethical and professional practices to ensure, no, that the system they build are of highest quality and that all design considerations are properly evaluated. Kasi there are certain cases that sorry to say, no, that there are some Filipino designers or programmers, okay na yan, pwede na yan. This will be the problem actually, no? So in many cases, this requires designer to exert strong leadership skills, to influence and negotiate with stakeholders, motivate the design team, and lead the design process to accomplish the project goals. Because another concern, no, and challenges in our country actually is on how we'll be able to collaborate with others, no? Which is too important also because we need to exert strong leadership skills as I mentioned earlier. Now, designers are also responsible for enforcing ethical guidelines during the design process, evaluating the social impacts of their designs in the public domain or in safety critical systems, and to follow the appropriate professional practices to ensure success in the overall system. So the ethical and professional practices aspect of software design are challenging because designers are constantly faced with numerous pressures from stakeholders that influence designers' decisions, most of which have consequences of social, ethical, or professional in nature. The other one, of course, the design challenge, of course, is the managing design influences. Because design are shaped by many different influences from our stakeholders. No? So the development organizations and other factors actually. And this influence can have cyclical effects between the system and its external influences, such that external factors affect the development of the system and the system affects its external factors. Because managing these influences is essential, no, for maximizing the quality of systems and their related influence on future business opportunities. Of specific importance are design influences that come from the system stakeholders and its developing organizations. Okay, a while ago, I mentioned about the stakeholders. Designing software is a non-deterministic activity. So if given the same task for different designers, different solution will be proposed, each of them being perfectly acceptable. Now add to the mix the multitude of influences that come from different stakeholders, and you can easily get a variety of design alternatives for meeting a variety of stakeholders concerned. all conflicting with each other. And this create a challenge when trading off design alternatives that meets all stakeholders concerned. Because making such design trade-offs is difficult, especially on large-scale design efforts. Consider a project with multiple customers, each with conflicting goal affecting design decisions. So in such project, creating a design that sacrifices some desired customer capability but provides other desired properties such as quick time to market, reliability, or lower cost can lead to the development of a high-quality system that maintains acceptable levels of satisfaction among stakeholders. Okay, and this is an example of how stakeholders affect design decision, and the design in turn influences the stakeholders' goal. Managing stakeholders influence are challenging because they are required designers to exert a high level of communication, negotiation, and technical skills to ensure that design decisions are made to accommodate all concerns without negatively affecting the project. Now, another concern, of course, is the development organization structure. Actually, it's too hard for us to look for a good web designer, a good database, good in database, good in for example in hardware, specifically for example the infrastructure. No, it's too hard for us to look for an IT practitioner who are good in documentations. This will be another challenge actually. So the development organization structure influences the development of software products, in particular the design of those products. So as example, consider the case of distributed software engineering. So in today's global market, more and more cases of distributed software development are taking place. So a wide variety of reasons exist for developing software at different sites. Now, consider companies that have sites in multiple states where various level of domain expertise are found at different sites. Or consider the case of software engineering resigning. No, creating a gap in the development team, hard to fill with local resources. And finally, consider companies that simply want to reduce costs by hiring software engineers from different countries. And this and many other reasons exist for having developed across site boundaries. And each of these cases, the structure of the development organizations make is complicated to coordinate design efforts, evaluate and discuss design alternatives, conduct peer reviews, manage version control in others. In these cases, designers are not only need to consider technical aspect of the design, but the distribution of employees, organizational goals, resource availability, and others. Design that support integration of distributed expertise across sites can introduce capabilities for building new software products that could not be engineered otherwise. And this in turn can influence the developing organization to target new areas of business. Therefore, allowing the software design to influence its business goals. Managing the influences of the development organization is challenging because it requires designers to span out of the technical domain to have a keen interest on the organizations as a whole. Okay, so therefore this will be the software design challenges. No? The requirements volatility, the process, the technology, the ethical and professional, and managing design influences. And I think that's it for the topic of Sir Alvin.